So just let's make sure, ya shabab, that we have achieved all of the objectives of this section. These are the main objectives of this section. If you remember, we have, I think we have accomplished all of these objectives, but let's go together and check them. So we said, ya shabab, at the beginning that the derivative, the first derivative will affect, of course, the graph of the function. What does it tell us about it? So let's say that we have a function y equals f of x, and here x, it is in the domain, or let's say it is an interval, or it is in a specific interval here. Now, the first thing that we had is the increasing decreasing test. Do you remember what does this test tell us? It says what? If the first derivative is positive or for some values of x inside some intervals, and when it is negative, what we have? If it is positive, what we have?
Increasing.
The function will be increasing, and if it is negative, the function will be decreasing. Okay, and you know also when it is zero, when the derivative is zero or does not exist, what do we have?
Asymptotes.
No, we should mention it here. If the derivative is zero or does not exist,
Critical value.
we have, let's say at c, at some numbers at c. If the derivative at c is zero, and then c is in the domain, طبعا, it should be also in the domain. So let's say here c is in the domain. First of all, it should be in the domain. C, it is in the domain of the function, and the derivative at that number is zero or does not exist, then c is a critical number. Let's just make it short like that. It is a critical number. So here the function is increasing, here the function is decreasing. So this is the first test that we had, the ID test. The first derivative test, what does it say, ya shabab? Do you remember the first derivative test? What does it say? It says what? If what? It is about what? The first derivative test. It is about the local and the local maximum and the minimum values. So it says that if you have a number c, let's say a critical number, if the function changes from being increasing to decreasing, what we have, and if it is changed to be from decreasing to increasing. So here the first derivative here is positive, here the first derivative is negative. So what we have in this case, maximum. We have what? Local maximum. In here, in this case, we have what? We have local minimum. Okay? So you know what we mean by the concavity up and down. So the concavity test, it is about what does the second derivative tell us about the original function. Do you remember the concavity test? It is about if the first derivative, the second derivative, I mean, if the second derivative at some interval over some interval is positive, what we have, and if it is negative, what we have. If the second derivative is positive, this means that the graph of the function will concave up. Cu will be concaving up. And if it is negative, then the function will concave down. The graph of the function will concave down, like this. The inflection point, so the inflection point, it is the point after it, let's say this is the inflection point P. So after it, it will be concaving up, and after that concaving down, or the opposite. So if this happening, it is the point at which the concavity will be changed from upward to downward. The final test that we had, I think we have stopped at this one, at this part. We didn't achieve it completely, this objective. So what we said about the second derivative, do you remember, Shabab? The second derivative test says what? If the derivative at some number is zero, then we have two cases. If the second derivative at that number is positive, what will happen? If the second derivative at that number is negative, what will happen? Do you remember? So first of all, it should be critical number. It should be the derivative at that number should be 0. So if the second derivative is positive, then we have what? We have local minimum at that number. And if it is negative, we have local maximum. And we have mentioned, ya shabab, that we don't need this test, because we have a test for the local maximum and the local minimum, the first derivative test. So mainly we need the second derivative for concavity up and down, but also it is okay, it is important in some problems. You cannot decide from there, you can use this one. But I said, I will repeat that several times, the first derivative test is more effective. We will see that together with some examples, okay? So this is the increasing decreasing test, ya shabab, or shortly the ID test. And we had an example about it. The first derivative test, we mentioned that it is about where it is changed from increasing to decreasing. You have local maximum, local minimum. Here we have neither, because it doesn't change. It's still increasing always. Here it is decreasing always. We had these examples for the concavity up and down. So if the first derivative, if the second derivative is positive, it concaves upward. If it is negative, it concaves downward. The inflection point, it is the point at which the graph will change from concavity down to up, or from up to down. You can use these information to sketch the graphs, but of course you need to add, ya shabab, some issues from your previous knowledge, from your previous experience to sketch the graph. Usually we will not ask you to sketch the graph especially in the multiple choice exams, but of course we will check that you are able to do that by asking you to find the inflection points, the critical numbers, the maximum, the minimum values, local or absolute, to find also the horizontal asymptotes, vertical asymptotes, and so on. So what I advise you, shabab, to do when you want to sketch a graph is to remember everything that you need about the graphs. You know, to sketch a graph, you need to find the end behavior. What will happen when it goes to infinity or negative infinity? What are the x-intercepts, the y-intercepts, the horizontal asymptotes, vertical asymptotes. Now you will add more things. Where it is increasing, where it is decreasing, where it concaves up, concave down, and also where it has a local maximum, local minimum. So all of these information now, they will help you to sketch the graph in an exact way. So this is, I think, the last part that we mentioned. Yes, I think we have stopped at this example in the previous class. So the second derivative test, as I said, sometimes it fails. It tells us nothing about it. We will see that. So if you have, if the second derivative is continuous near a number, C, and the first derivative at that number is 0, and the second derivative is positive, then this is the local minimum. The function has a local minimum at that number. But if the second derivative is negative, it will be local maximum. But what about if the second derivative is 0? It is not positive, not negative, I don't know. In this case, the test will fail. The test will tell you nothing about this point. If it is 0, the function, the second derivative at C, it is 0, for example. In that case, we cannot decide. Let's apply it for this. So let's apply all what we have studied before for this function. Now, what we should start with, ya shabab. Taban, he wants at the end to sketch the curve. But let's focus on the what? The concavity, points of inflection, local maximum and minimum, and so on. So it is okay to start with what?
Find
with
the derivative.
Find the first derivative and the second, by the way. We need to apply this since we are talking about it. So let's use it. So you will find the first derivative, the second, the first derivative, then the second. But of course, don't stop here, because you want to find the critical numbers. You need to factor it. Take 4x squared as a common factor. Here, take 12x as a common factor. Since this is a polynomial, shabab, it is so easy. The domain is all the real numbers, so it is defined everywhere. Also, the second derivative, the first derivative, they are defined everywhere. The domain is all the real numbers. And of course, shabab, you should keep in mind something about this function. It is polynomial of degree 4, and the leading coefficient is positive. So how it will behave at the end? So it will be up to the right, up to the left. Do you remember that? from your
Yes.
previous knowledge, from your previous experience. Now, since it will do that, it must, whatever it will do, whatever it do, it must have absolute, not only local, it should have absolute minimum in this case. So, and you know, in that case, of course, it could be absolute and local at the same time. Now, we will try to find out what is this local minimum. So I know now that it has a local minimum. It could have local maximum, by the way, but it has local and absolute maximum. طبعا, it is also easy for you to know the zeros. If you want to know what are the x-intercepts, take x cubed as a common factor. It will be x minus 4. So you know now that this function, so look how much I know about this function. This is the x-axis, this is the y-axis. It will be here, up to the right, up to the left. It has x-intercept at what? At 0.
0 and at 4.
And at 4. So it will cross the x-axis here. It will go down. Then it will comes back to cross, and it will be something like this. Now I need to know, to decide what is this number, at which number, where it has a local maximum or absolute minimum, and what is the value of that one. Also, I need to know where it is concaving up and down, where it is increasing and decreasing exactly. So this is what we need to do more. If it was just about the sketch, we can do it. Now what we need to do, ya shabab, let's apply this by the way. Let's find first where the derivative is equal to. Let's find the critical numbers. Do you remember what are the critical numbers? They are numbers in the domain. The domain here is all the real numbers. Don't worry. So here we need, so this derivative, the derivative, it exists everywhere. So just we need to find where it is 0. Of course, if for other functions, we should check does not exist also. But here, the derivative is defined everywhere, so it exists everywhere. So there is no numbers at which it does not exist. So the derivative equals to 0. The first derivative equals to 0. This means that what? This equals to 0. This means that x is 0 or x is 3. So these are the critical numbers. Now, if you want to check which one of them is absolute, which one of them is local maximum, local minimum, what you need to do, you need either to make a table for the first derivative to know where it is increasing, where it is decreasing, and where it will have minimum or maximum. This is one way. But you can also choose use this test. Just find the second derivative. Find the second derivative at 0 and the second derivative at 3, and see what will happen. Let's start with the second derivative at 3. What is the value of the second derivative? This second derivative at 3. Is it positive or negative? Don't evaluate it exactly.
Positive.
If this is 3, this will be positive, and this will, so it is positive. So here we have what, ya shabab, according to the test?
Minimum.
Local minimum. There is a local minimum at 3. So the local minimum here will be at 3. What is it? It is the value of the function here, the value of the function at 3. Go to the original function, put instead of x3, and you will be able to find out what is that value. And we will see it in the next slides. Now, what about 0? The second derivative at 0. This is the second derivative. What is the value of the second derivative? 0? Oh, it is 0. So we have no idea. This test fails because we don't know. It will be local minimum or maximum. We don't know. So we need to check by using the first derivative test. How to check? It could be maximum. It could be minimum. It could be neither, ya shabab. So to do that, to check at 0, you need to use the first derivative. So to use the first derivative test here, what we need to do, let's do it here together. So to do that, this is what I said. Since the derivative at 3 is 0, the second derivative is positive, and the value of the function is a local minimum. Here it is negative 27. The value that we are looking here, it is negative 27. Now, for 0, we say that the second derivative at 0, it is 0. So the second derivative test gives no information about the critical number 0. It fails. So this means that it could be minimum, maximum, or neither. So now what to do? You need to check. Let's remember together what was the second derivative, ya shabab? The first derivative, what it was. The first derivative was 4x squared times x minus 3. Now we need to use the test what are the critical numbers? The critical numbers are 0 and 3. These are the critical numbers, 0 and 3. So we need to study now the behavior of the first derivative at this number. طبعا don't worry about this يا شباب. What are the zeros? The 0 are 0, 3. For this one, x squared, it is always what? So x squared, it is always. So don't worry about it. خلاص, it is positive always. Focus on this. X minus 3. What is the 0 of x minus 3? It is 0.
3.
At 3. So x is positive. So it will be positive after that, negative before that. Now, here the function is what? Decreasing, decreasing, increasing. So here we have local minimum, and we know that from before. And it is not only local, by the way, it is absolute. But at 0 log, the derivative change, it does not change the sign. It is still negative, negative. So it is decreasing, decreasing. So here we have no local minima and maxima. So we have no local minimum, no local maximum. So we know that it has nothing there, but it doesn't mean that it always happens. It could be local minimum and maximum by using the first derivative test. So now we need ya shabab to decide where it concaves up and down. So to know that, we need to go back to the second derivative and decide where it is positive, where it is negative, if you remember. So what we will do now, we will study the second derivative. Let me do it here, the second derivative. But we need to know first what is the second derivative. Let's remember. The second derivative is what? It is 12. We can have it from here. It is 12x times x minus 2. 12x times x minus 2. Now the second derivative, shabab. Let's do the table or the table of signs for the second derivative. This is the second derivative. Now, what are the zeros here, shabab? 0 and 2. طبعا it is also sometimes to include the critical numbers, to have them. You can have both second derivative and first derivative on the same table, but you have to consider all the zeros of them, both of them. So now after 0, this will be positive, 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 and before it negative, because we have x here. X minus 2, it will be positive after 2, negative before that. So combine them, positive times positive, it will be positive. Here it will be negative, and here it will be positive. So this is the second derivative. Now here it will concave up, down, up. We are talking about f here. So here it is C, U, here it is C, D, C, U. So now I think we are ready to sketch the graph, shabab. So to sketch the graph, you need to combine all of this information. Oh, there is something we should mention here. Do we have inflection points, ya shabab? The inflection point, this one, it's changed from concaving up to concave down. So this one, this point, it is inflection point. This one, it is inflection point. So you need to find 0 and what? 0, what is the y? You need to substitute in the function. And 2 and what? They are inflection points. So here we are, 0 and 0, 2 and negative 16. These are the inflection points at which the graph will change its concavity. Now to combine all the information, I think we had an example, and I did sketch the graph for you before in the previous slide. Here we are. Look, you need to check everything that you did before. So this is the local and absolute at the same time minimum. The behavior up to the right, up to the left. At 0 it is 0, and at 0 we have inflection point, so it should change from concave up to concave down. Look, this is the meaning of inflection point. Here at 2, it was here before, it was concave down, after that it will concave up. And of course you can also check the x-intercepts. And what about increasing and decreasing? We say that the function, we mentioned that it will have a local maximum and local minimum. Do we have a local maximum at 0? No, it is neither. We have only one local and absolute minimum. It is increasing after that, decreasing before that. So it is decreasing before 3, increasing after 3. Excellent. Now, as I mentioned this before, that the second derivative test, sometimes it is inconclusive when the second derivative is zero. In other words, at such point, there might be maximum, minimum, or neither. The test also fails when the second derivative at C does not exist. This is another case. So it fails in two cases. In that case, if the second derivative test fails, what we should do, we should go back to the first derivative tests. It must be used innocent. Another example, we have here a very interesting type of functions. I have noticed that in the old exams there are many, and also in the recitation and the homework problems. You should focus on this type of function, Shabab. You should practice it because when you find the first derivative and the second derivative, it takes time from you to do that. So what I did, I just here write the final answer for the first derivative. But how you obtain this, you should be able to do that from your previous knowledge. So let's do it together to practice. You should do that, Shabab. The first derivative, how to find it for this function. You will use what?
Product rule.
So it will be the first one times the second. The second derivative, what is it? It is third times 6 minus x to the power what?
Minus
to the
2 over
power
3.
negative 2 over 3.
Multiplied
Are we
by
done?
minus 1. Minus 1.
Multiplied by the derivative of the insider function by the chain rule. So multiplied by negative 1. Plus, this is the first time this derivative of the second. Look, this is the derivative of the second, ya shabab. Now the second multiplied by the derivative of the first. So this is the second. Now multiplied by the derivative of this. The derivative of this, it is 2/3 x to the power 2/3 minus 1, it is negative third. Look, is it the same as this? How can you guess that? You need to do a lot of work, ya shabab, to simplify it. Because why we need to simplify it? Because we want to find the critical number. So we want to know where it is zero or where it does not exist. Excellent. Also, I advise you, Shabab, always to find the domain of the function at the beginning. If you look at this function, who can tell me what will be the domain of this function?
Or real number except 6 and 0.
Why? What will happen at 0 and 6? It is all the real numbers indeed. All the real numbers. No problem.
I was looking about the derivative.
Oh, they are odd. No, I'm talking about the function. They
Okay.
are odd, ya shabab, radicals, not even. If they are even radicals, we should consider only the positive numbers. Okay, so we need to simplify here, ya shabab. How to simplify such type of functions, please? What we need to do here, ya shabab, is to take a common factor. So the common factor between third and 2/3, we will take third. Okay, and between x to the power 2/3 and x to the power negative third, we will take the smaller. We will take negative third. Between this and this, we will take 6 minus x to the power smaller power, which is negative 2 over 3. Now open brackets. Here, divide third by third, it will be 1. This over this, it will be x to the power what?
1.
2/3 minus plus third, it will be 1 to the power 1. And we are done. Oh, we still have negative here. Don't forget it. So we have negative x here, not x. Don't forget this negative. Plus 2/3 over third, it will be 2. This over itself, it is 1. This over this, it will give you 1 also. This to the power 1. Now this is the second derivative. You need to simplify this, ya shabab. To simplify it, what it will be? It will be 1 over 3. This will be in the denominator, 1 over x to the power third. Also that one will be in the denominator, 6 minus x to the power 2/3. Now what we left up with up here, Shabab, we have what? Negative x plus 12 minus 2x. So what is it?
12 minus 3x.
It is 12 minus 3x. So we have here 12 minus 3x. Now take a 3 as a common factor and cancel it with this 3. So what do you have? You will have 4 minus x. And if you look, here we are. This is the first derivative in the most simpler form. You should do that always when you find the first derivative. Now you can find the critical numbers. What you will do to find the critical numbers, you will put it equals to what? to 0. Now, if this is equals to 0, Shabab, what we have, we will do that. I will, by the way, now you need to sketch the graph of this function. It means you need to find also the second derivative, the concavity up and down, reflection points, and so on, inflection points. So I will leave finding the second derivative. And this is why I said, Shabab, if you can avoid finding the second derivative, no need to do that. Because it will take time now to find the second derivative now. Look what we did to find the first. Now to apply or to find the second derivative, you need to apply the quotient rule or the product, by the way. You can also write this in the denominator and apply and find the second derivative. So this will be the second derivative. I will let finding that for you. Please find it and check your work. Now let's find the critical numbers. How to find the critical numbers, ya shabab? We need to look at the numbers at which the derivative is 0 or does not exist. So we need to check where it is 0. This will be 0 where? Of course, when the denominator is 0. So it will be 0 at 4. Where it does not exist?
At 0 and 6.
0 and 6.
Check the 0 of the denominator. So it is at 0 and 6. Are they in the domain? Don't worry here. The domain is all the real numbers. So always, Shabab, don't forget to check that the critical numbers must be in the domain. If they are not in the domain, they are not critical numbers. Now we have the critical numbers. So what we need to do to make a table of values, the table of signs. So this is the first derivative. Now we have 0, 4, and 6. Now look at the first derivative. Here, there is a term that we didn't, we don't need to worry about. Which one is this one? This one is always positive. Am I right?
Yes.
Why it is always positive? Because it is 6 minus x all squared under the cubic root. So this one is always positive. So don't worry about it. Just focus on this one and this one. So the 0 of this is 0. So this term, after 0, it will be positive. Before 0, it will be negative. Now for this term, you have to be careful. This is not x minus 4, ya shabab, as usual. This is 4 minus x. So if you have x minus 4, if you have, if you have x minus 4, it will be this case. It will be positive to the right, negative to the left. But when it is, I will leave it for you here. If it is 4 minus x, it will be the opposite. It will be negative to the right, positive to the left. You can choose any value greater than 4. Look what will happen. So here, for this term, after 4, it will be negative. Before that, it will be positive. So in general now, the first derivative will be what here? It will be here negative. Here it will be positive. Here it will be negative. Here it will be negative. So now we know that now that here it will be decreasing. The function will be decreasing. Here increasing, decreasing, decreasing. So what we conclude, ya shabab, here at 0, what we have? We have local minimum. Am I right? And at 4, we have local maximum. Because it is changed from negative to positive, from decreasing to increasing. But at 6, we have nothing. We have neither minimum or maximum value. Is that clear now? You can, Shabab, start now working on your graph from the beginning. Find the x-intercept, y-intercept, the end behavior, and start do whatever you can do about it. And of course, you can now start thinking about the local and minimum and maximum. What else, ya Shabab, we need to do now? We need to find the inflection points, the concavity. So we need the second derivative to use the second derivative. This is the table. I think the table this way is better than using this way, as I mentioned to you before. Now you need to look at the second derivative now to know where it is concaving up and down. Here it is. This is the test, but let me mention for you by the method, the usual method that we have. This is the second derivative. Look at the second derivative. What are the zeros that you may have? It is never ever 0, by the way, because the denominator is 0. But it will change the signs about what? 0, and 6. But look here, this is always what?
Positive.
Positive. So it is always positive. So don't worry about it. So it will be positive, positive, positive here. But look at this now. Forget about 0. Focus on 6. You have here 6 minus x to the power here. All of them are even. So it could be, what will happen? It will be negative after to the right of 6 and positive before that. You can just take a number greater than 6 to check that. Now here it will concave what? The function itself. The function here, it will concave up, concave down. You can use this notation or this notation. It is up to you. Okay, so now what we have, do we have here inflection point?
No.
Here we have inflection point.
Yes.
We have inflection point where it changed from concave up to concave down. So excellent. So you need to find 6 and what is the inflection point? The value of the function at what? It is 6 and 0. Okay, now you are ready to combine all of this information to sketch the graph. And you, as I said, usually we will not ask you to do that unless maybe in the quizzes we will do. Now, what you need to do, you need to combine all the information that you had before. Also, you may think about, he mentioned here the vertical tangents. Of course, the function has vertical tangents because the first derivative, it is undefined at 0 and at 6. So at these two numbers, we have vertical tangents where, you know, when we have a vertical tangents, when the derivative, the first derivative is undefined, does not exist. So here we have the graph should have at 0 vertical tangent. So it has a corner there or a vertical tangent like this. Now, what else? Here it concave what? Down. And it's still concave down. It will not change. It keeps concaving down until what? Until 6. After 6 and 0, it will change the concavity. And this is what we say. Also, if you notice, it is decreasing here, increasing after that from 0 to 4. After that, it is decreasing. And this is also, we mentioned that before. It has a local minimum here and local maximum at 4. Only at this number. So you need to check, when you sketch the graph, you need to check all the information that you had before. Are they valid or not? The graph, of course, it might change, the details of the graph, but in general, you may, for example, some of you, they may sketch the graph like this. But of course, here you have the exact values, so it doesn't matter how it will behave like this, for example. It's okay. But since we have a vertical tangent here, you should mention it also. Let's take I think we have another example, and it is the last one. Use the first and the second derivative of the function together with the asymptotes to sketch the graph. So let's start with the easier one, the asymptotes. This is, of course, previous knowledge. How to find the asymptotes of this function, Shabab? You have now.
When the limit goes to 0 and to infinity.
You need to think about two things, about the vertical asymptotes and the horizontal asymptotes. Okay, do you remember which one is easier, Shabab? What do you think?
Vertical.
The vertical. Yalla, let's start with the vertical. If there is a vertical, it will be where, Shabab? This is e to the power 1 over x.
At 0.
At 0. So we need to find the limit of the function when x goes to 0 from the right and from the left. So what it will be? Yalla, Shabab, limits, chapter 2.
Positive infinity.
In both cases?
No, when 0 plus.
Here it will be e to the power 1 over 0 plus. Here it will be, let's say approximately, let's say it goes to be more accurate. 1 over 0 minus. So this will be what? E to the power what? It goes, let's say also it goes, not necessarily equals. To e to the power
infinity.
What? Infinity, positive infinity. So this will goes to where? Infinity. And here?
Negative infinity.
Which is 1 over infinity, e to the power infinity, which is 1 over infinity. So it will goes to where? It goes to where?
0.
0, not infinity. Aha. So what do we have? Where we have a vertical asymptote. So what is the vertical asymptote? The vertical asymptote, it is x equals what? 0. So now, which is the y-axis. So at y-axis, what will happen? You should keep this in mind when you sketch the graph. When x approaching 0 from the right, the graph will go to infinity. When it is approaching 0 from the left, what will happen? It is not defined at 0. The function is not defined at 0, so we have open circle. When x goes to 0 from the left, it will approach 0. So it might approach like this, or like this, or whatever, like this. I don't know. So from the left, it will approach 0. Let's say it is approaching it like this. And we will see that later. So we know now something about the graph from the beginning, just from the asymptote. Thank you, guys. It looks like you still remember these issues. Good. Now for the horizontal asymptote, what we should do, ya shabab, to find the horizontal asymptote? We should find the limit of the function when x goes to where?
Infinity and minus infinity.
Infinity and negative infinity. Excellent. So what is the limit? What is the function? This is our function. Our function, it is e to the power 1 over x, e to the power 1 over x. Now this will goes to where, shabab? If x goes to infinity, this will goes to e to the power 0,
1,
which is 1. And this one, when x goes to negative infinity,
also 1.
Are sure? It will be e to the power negative 0, which is negative 0 is 0.
Yes.
So it will be also e to the power 0, it is 1. You are right. Because this is always positive, shabab, whatever the power is. So what do we have here? What is the horizontal asymptote? It is y equals what? Y equals 1. So now we have additional informations. So this is the x-axis, this is the y equals 1. This is the horizontal asymptote. Usually we write it with dots like this. Now we know that the graph is doing like this here. So it for sure, it will do something here like this. So we can say that the graph will be like this. So it concave up. We will check that later. And what happened here? We said that it will be like this and it will be approaching like this. So now I think we have some idea about the graph. It cannot be above it, shabab, because it should approach 0 from the left. Now, what we need the first and the second derivative to help me to make sure about this graph. So what we will do, we will find the first derivative. This is the first derivative. You know how to find the first derivative. It is the exponential, it is the same, multiplied by the derivative of 1 over x. The derivative of 1 over x, it is negative 1 over x squared. Now, let's find the critical numbers. So what we do, we put this equals to 0, and we need to ask ourselves where it does not exist. طبعا this cannot be 0, shabab. If you put this equals to 0, impossible. Because if this is equals to 0, it means the numerator is 0. And the numerator, it is always positive. It cannot be 0. So this one has no solution. If prime at 0 equals to 0, that have no solution. What about does not exist? The first derivative does not exist where?
At 0, but 0, it's not on the domain.
At x equals 0. So this is a critical number. Can we say that it is a critical number?
No,
No. Why?
it's not in the domain of the original function.
We should find the domain from the beginning. I forget to mention that. Look, you should find the domain, ya shabab. Always start with finding the domain. So if you mentioned here that the domain of this function is all the real numbers except 0. So you can write it as all are real numbers just without 0. So it is not in the domain. So it is not a critical number. So to be a critical number, it must be first in the domain. So what we conclude from that, shabab, no critical numbers, la? Here
Yes.
we have nothing here. So
Yes.
no critical numbers, no critical numbers. So no critical numbers means what?
It's always decreasing.
It always decreasing.
No. No critical numbers means what?
No maximum or minimum.
Yes, no local no local maximum. Yeah, Shabab, if there is a local, you remember there is a theorem about that. If you have a local minimum or a local maximum at some number, then this number must be a critical number. So no critical numbers, no local minimum or maximum. And you can make sure about that. How? By studying the first derivative, sine. So make a table of sine for this, for the first derivative. If you want, no need here, it is clear. Here, we said that where we will study it, by the way, we don't know. Just we have the function is not defined at 0. So this is what we have. But of course, no need to do that because it is clearly, this is always positive. This is always positive. So what we have, positive over positive is positive. Positive times negative is negative. So it is always what?
Decreasing. Negative.
Always decreasing. And this will make sure that there is no maximum or minimum because it is always doing like this, decreasing. But of course, it is not continuous at 0. Excellent. So this what we say here, the second derivative, it is negative for all the values in the domain, for all x does not equals to 0. So it is increasing always on the domain. Now, if you want to do more, if you want to know where it is concave up and down, you can find the second derivative. And this is what we mentioned. If you want to find the second derivative, you need to apply the quotient rule. You have to be careful, and this will be the second derivative at the end. If you look at the second derivative now, you need to find the inflection points if they ask about the inflection point, or if they ask about the concavity up and down. Now, this is always positive. This is always positive. Don't worry about that. You need to find the 0 of this. It is negative half. So this is negative half, and it is clearly after negative half, it will be positive. Here it will be negative. So here it will concave down. Here it will concave up, and here we have inflection point. Okay, that's it. So if you combine all of this information, ya shabab, at the end, this is the inflection point. If you combine all of this, look, we said that it has a, when x goes to 0 from the right, it will goes up like this. It has, of course, horizontal asymptote at 1. It approaches 0 from the left. And it has also here horizontal asymptote. It cannot be crossed at the end. So if you combine this is the negative half is here. So we have inflection point at negative half. So it will change from concaving down to concaving up. So we can do it like this. And after negative half, it keeps concaving up. But here it is here. Here it is concave up. And I think this is similar to the shape that we suggested at the beginning. Now you need, when you have your final graph, your finished sketch, you need to verify that all what you have obtained before is valid here. These are Shabab suggested exercises. Again, I advise you to solve, especially this, the homework, because you already solve, or you will solve the recitation exercises with your recitation instructor. But of course, it is important also to solve these suggested. They will consider it when they set some problems for the final. And of course, the examples of the book, the exercises, as well as the old exams. Let's check that you are okay and you can solve now this. Please, Shabab, solve this exercise. Find the local minimum. Oh no, he didn't want. Doesn't want the local minimum. He wants it occurs where? Where we have a local minimum, not what is the local minimum value. Find the local minimum points. At which point we have a local minimum for this function. This exercise, by the way, this question was in 4.1. I changed it. I moved that one from there to here. I think you cannot solve it with the ideas of 4.1, but try. I think I will give you 1 minute, 2 minutes, because we don't have much time. Don't forget, Shabab, we have, inshallah, next class, we have quiz number 11. And it cannot be delayed anymore.
Thank you, Doctor.
Yes?
Well, thank you, Doctor.
Welcome. What you will do, ya Shabab, to find the local minimum?
The
Find
first
the derivative.
Find the first derivative. Excellent. Yalla, ya Shabab. I advise you always to find the domain if it is easy. If it will not take time from you. If you look at this, the domain of this function is what? X is okay, x squared is okay, ln x, we have ln x, so it is from 0 to infinity.
0 to infinity.
So all the positive numbers here. So if you obtain critical numbers that they are not in this domain, you should reject them. So the first derivative is, derivative of x is 1 minus 1 over 6. The derivative of x squared, it is 2x. So this will be simplified to what? To third x. minus 2/3 ln x, the derivative of ln x, it is 1 over x. This is the first derivative, يا شباب. So what we should do now? We should check where it is 0 and where it does not exist. طبعا it does not exist at what?
At 0.
Zero.
0.
At 0, it is not in the domain. It is not in the domain of the function. So that you must reject this. So it is rejected. So focus on this only. Where it is equals to 0. So to find out where it exists to 0, where it is equals to 0, you need to simplify this. So let's write it as what? The LCD is 3x. Am I right? Here you need to multiply by 3x. Minus here you need to multiply by x. So it will be what? X squared. Minus here you have everything. This is the derivative, يا شباب. Now you need to set this one, put it equals to 0. When you put this equals to 0, what you will have? You will have the denominator equal to 0. So this implies that this equals to 0. 3x minus x squared minus 2 equals to 0. You need to solve it. It will be x squared minus 3x plus 2 equals to 0. You need to multiply by negative 1. Now you need to factor this. It will be x minus 1
Minus
times
2. Minus 2.
So we have, يا شباب, two critical numbers, x equals 1 and x equals 2. So you have now, this one is a choice, this one is a choice, this one is not a choice, not a choice, not a choice. So if there is an answer, it will be only 1 or 2. Now, if you want to use the first derivative only, put x equals to 1, put x equals to 2, what you will have? If you put x equals to 1, you will have 1 minus third minus 2/3. Which is clearly what, يا شباب?
0.
No, where I'm putting this. We said f, not f, not the derivative. This is a common mistake. I do this usually. I don't know why. So be careful about it. We are talking about f, not the function. So what we have again? So we have 1 minus 1 over 6 minus 2 over 3rd times ln 1. Ln 1 is 0. So it will be 5 over 6.
Positive.
Positive. No, it doesn't matter. It's positive or negative. It doesn't matter here. We're talking about the function itself. Now, the larger one will be the maximum, the smaller value will be the minimum. Now, both x equals 2. It will be what? 2 minus 1 over 6. It will be 2. 4 over. It is 2 over 3 minus 2 over 3 ln 2. Aha, we don't know. مثلا لو كانت هذه 1 يا شباب. لو كانت هذه 1 مثلا. Which will be the minimum? The minimum will be this. And this will be the maximum. But now we cannot decide, the shabab, because of this. We cannot decide because of ln 2.
We can make a table.
Make a table for what? I need to find the local minimum and maximum, shabab.
Make a table.
Because of ln 2, how can you decide, ya shabab? So you can make a table of values. Well, do whatever. It will not be that easy. You will make a table of value for 1 and 2. You will see where it is positive, where it is negative. But I said again, you have to be careful about that. Yes, this is the value, where it is, here it is. You can make a table of values and decide. This is one way. But there is an easier way, shabab. What is it? There is one thing that we can do about. Find the second derivative. What will be the second derivative? The second derivative is 0, negative third, negative 2 over 3 to the derivative of 1 over x. It is 1 over x squared negative, so it will be plus. So this is the second derivative now. Do you remember the second derivative test? We will put now the second derivative equals to 1, the second derivative equals to 2, and we will see. If it is negative, it is local maximum. If it is positive, it is local minimum. So let's see what will happen. Both x equals to 1 here. What you will have? You will have negative third plus 2 over 3. What is it? Third. It is positive. So here we have local minimum. Now, if you put x equals to 2, you will have local maximum. Check that. It will be 1 over 4. It will be negative. So you have here local maximum. Okay, Shabab, this is all what we have for today.
So what's the answer?
Just let me, Shabab, dismiss this alarm.
1.
Answer is 1.
Yes. Yes, what you said?
The answer is 1.
Yes, the answer is 1. The local minimum. He's asking about the local minimum. The answer is 1. اوكي
دكتور
يس
لما نسوي تشيك يعني طلعنا x equals 1 و x equals 2 نسوي في الاوريجينال فانكشن ولا الديريفيتيف؟
check what you mean by check here
عشان اذا هي تسوي 0 ولا لا.
تساوي الزيرو ولا لا؟ ما فهمت قصدك. احنا اصلا جبناهم لما حطينا الفيرست ديريفيتيف تساوي زيرو. هم منين جو الاكس equals 1 و x equals 2؟ They are coming from where؟